Hey guys, so today we're going to be looking at a continuation of lesson 1 where we're simplifying radicals, but we're going to be looking at removing variable factors. So you are going to see now radicals that include variables with exponents. For example, if you saw the square root of 45a to the 6th. So first you would deal with the numerical part, the number 45, and try to find any perfect squares that go into 45. So 9 is a perfect square that goes into 45. So 9 times 5, I'm rewriting 45 as 9 times 5. And it's important to recognize that with variables, any exponent that is even exponents is considered to be a perfect square, are perfect squares. So the square root of a to the 6th is just a to the 3rd. Because remember, in exponents, when we multiply exponents, we actually add the exponents, because a to the 3rd times a to the 3rd equals a to the 6th. So if you have, under the square root, if you have a variable that's already a perfect square, then you leave it like that, and you're going to take its square root. So you're going to take the square root of 9, because you can take its square root, it's rational, and you're also going to take the square root of a to the 6th. And you're going to remove those two and put them on the outside of the radical, because those two are rational. So the square root of 9 is 3. The square root of a to the 6th is a to the 3rd. The only part of this that can't be, that you can't take its square root without getting an irrational, is the square root of 5. So our final answer is 3a cubed times the square root of 5. Now, if the example had instead read as the square root of 45a to the 7th, now that's an odd exponent. Odd exponents are not perfect squares. So what we do is we break them down, kind of like that we do with the 45. So 45 we know is 9 times 5. And we break down a to the 7th as a to the 6th times a. So what we do is we basically remove the biggest even number that you can subtract away from that exponent, in this case a to the 7th. So a to the 6th is the biggest even exponent that goes into it, times you would need one more a to multiply to get you to a to the 7th. Now you can take the square root of all the rational parts, the square root, or the perfect squares, square root of 9 and square root of a to the 6th. So this time what would be left under the radical symbol would be the 5 and the a, because a to the 1st is not a perfect square. So the square root of 9 is 3, the square root of a to the 6th is a to the 3rd, and my final answer would be 3a cubed times the square root of 5a. Okay, we'll do some more examples to show this. So example 2. The square root of 60a to the 5th, b to the 8th. So 60, automatically 6 times 10 comes to mind, but we don't want to use 6 times 10 because neither of those are perfect squares. So instead we're searching for a perfect square that goes into 60. 4 goes into 60. So 60 is really 4 times 15. And when I look at the variables, if I have an odd exponent like a to the 5th, I'm going to break it down into a to the 4th times a. Basically the biggest even number that can be subtracted from it. And then b to the 8th is already an even exponent. That's a perfect square. I'm going to keep it like that. Okay, if it's a perfect square, you leave it like that. And so I'm going to circle the ones that I could take the square root of. I could take the square root of 4, the square root of a to the 4th, and the square root of b to the 8th. So the square root of 4 comes out, it's 2. Square root of a to the 4th is a squared. Square root of b to the 8th is b to the 4th. And what remains under the radical is the 15 times the a. And outside I have 2a squared b to the 4th. Okay, take a look at another one. Example 3. We're doing this again. I never know why it does that. Okay, I'll do this. Example 3. Find the square root of, and this time I have a variable on the outside. So I'll have b times the square root of 27 b to the third c to the 10th. Okay, and feel free to pause the video and try this on your own. So I'm going to break down 27 into 9 times 3. B cubed is odd. I'm going to break it down into b squared times b. And c to the 10th is even, so that's a perfect square. I'm going to leave it. And I'm going to circle the ones that are perfect squares. I could take the square root of 9, I could take the square root of b squared, and I could take the square root of c to the 10th. Square root of 9 is 3, comes out. Square root of b squared is b, which is going to multiply by the b that's already out there. And the square root of c to the 10th is c to the 5th. So final answer is 3b squared, because I'm multiplying by that b that was already out there, times c to the 5th, times the square root of 3b. Okay, and you guys are going to practice a bunch like this for homework. This is not due till Thursday because you guys have a test tomorrow to prepare for. Okay, thanks.